Hello and welcome back. If you follow the channel, you know that we love all things Apollo. We restored an Apollo guidance computer and then got busy restoring the entire Apollo communication system. Recently we started restoring the Disky, the iconic computer interface that was sitting in the middle of the spacecraft's control panel. But there is another iconic panel instrument that we have been itching to play with. The Flight Director Attitude Indicator, or FDAI, nicknamed the 8-ball indicator. It really looks like it houses a high-tech billiard ball inside. Its main function is to display the orientation of the spacecraft. It does this by rotating around all three axes by some mechanical magic that I am eager to discover. Although it looks similar to a conventional aircraft attitude indicator, it is quite different. Traditional artificial horizon indicators rotate around only two axes, pitch and roll, which works well enough on Earth but is not sufficient for a spacecraft. Apollo's FDAI was made by the aircraft instrumentation company Lear-Siegler. We haven't gotten our hands on a real Apollo FDAI yet, but we just got the next best thing. It's a pair of ARU-11A attitude indicators, also made by Lear-Siegler. They were used in a Phantom F-4 fighter jet of similar vintage. They have the same fully rotating ball, and being made by the same company, their internal construction should be similar. The first unit, the blue-gray one, was rescued from the scrap bin by our super patron John Pumpkinhead, who has donated many items to the channel already. We don't think it's functional, so it will be our guinea pig for reverse engineering and maybe our first power-up experiments. The black one is on loan from patron RJ Gritter. It looks complete. Moreover, RJ has a few more backups in case we need some, which, as you'll see, will come in handy. Thank you for your generosity and trust, RJ. But for now, let's steer into our bin rescue indicator. I can't wait to see the secret behind the ball actuation. So on the bench we have two attitude indicators from Lear-Siegler, which is the same one that made the indicators in the Apollo. So it's like an 8-ball or an FDI kind of thing. It has 3 degrees of freedom. And after a minimum of blunt trauma and effort, we open one up which had been opened before we did it, so it's missing stuff. And Ken, what have you found?
Well, it's basically motors and feedback, so there's got to be an external amplifier that drives it all. There's this very nice complex slip ring assembly in the middle.
So there's some stuff in the ball to make it rotate.
It looks like 2 of the axes are inside the ball, because this one up here is just the rotation, so there must be another slip ring inside the ball.
Oh, the motor is inside to do this.
Yeah.
And then you have another motor. There's a slot right here that allows for yet another rotation. It's very clever, but if we don't have the amplifier electronics, I am a little bit flabbergasted to how this would work. And then we're missing, there's 4, what I suspect are adjustment pots. There are 2 wires that go to each of them. And there was nothing. These have been obviously ripped off or cut. And whatever this is, pots are completely missing and the 2 wires are cut. So this is a little bit mysterious. And I don't know if that one is different. It has more stuff to it. It has more indicators, and the actual Apollo FDAI had indicators of the wazoo. It had this crosshairs plus 2 or 3 indicators on each side. Okay, if no electronics, how do you do the servo loop?
So it's going to be external amplifier, because you've got your motor and your position sensor. So it's both simpler and more complicated inside than I was expecting.
Yeah. Well, you can open the ball. There's some screws in there. And to open it up, all you had to do is to get the soldered band around it. You take that one off. And the connectors, they go off automatically. They get out from there. And I'm not sure what should happen to the pots in reality. Actually, I took the clips off. They were little clips. I don't know if that's supposed just to fall off, but it just looks like it's supposed to slide off. So this poor unit has been monkeyed with, and there are two sets of wires that are not connected to anything over here and over here, and I think we have two actuators missing. There were some screws that were not in, and there was one screw that's the wrong type. So something happened. It was a parts device and stuff was removed from it. So we have progressed in our disassembly and found that there was more modification / damage. So I guess this here must have been another control transformer or something. And you say the anti-backlash?
Yeah, see, this gear is actually 2 gears that are spring to force in opposite directions, so you're always in contact with the other gear.
Yeah, anti-backlash wheel. Yep. I think if I can get that out and get that out, I can get the ball out. Whip. Beautiful. And can I take this one off? Yep. Here we go.
Very fancy.
That is nice. Yep, so two motors and 2 synchro. Yeah, you can see them, that's what you expect.
I wasn't expecting a cube though.
I suppose we could take the bottom shell too. And there's a slip ring inside this thing. If you look at here, there must be a slip ring inside here, because I see all the wires going through.
Yeah, I figured we had to have slip rings in there.
Okay, so let me see if I should be able to open this up. I figure out there must be an orientation to this, which I probably completely screwed up.
Yeah, can you mark this against the axis? Or
I can't because that turns. How would we know? I'm going to put the north over here when I take it, and I'll put a mark underneath.
Our F4 is going to go off in the wrong direction.
Yeah, don't fly this. Oh, wait. This, yeah, oh, that's already the mark. That's north. It already has it right there. This is north. Oop, this one over here. Okay, so interesting that this is. Oh, I should know. Oh, this is the brake. This is the alignment brake. So I went a little too far in my disassembly here. Okay, I have to put those 2 screws back. I went too far here in the disassembly. This stays.
A few minutes later.
So I think we have recovered. This is some sort of tilt adjustment. Once you've put the globe in. Okay, but it's back together. And then we have the north indication, so we're good. It's a very clever arrangement of 3 servo motors and 3 synchro transformers.
And then here you can see the slip rings.
Yes, over right here, the brown stuff. Let me see if I can focus on it. Yeah, right there, at the very bottom. Yeah. Slip rings, so it has 2 slip rings.
And then here are the contacts for the slip rings.
Yeah.
The connections.
Oh, and another one of these blocks, so they appear to be genuine.
Yeah.
So the one we have here,
That one.
yeah, it seems to be genuine. So it's probably in a different version of this instrument that has one more axis or one more little needle.
The 4-dimensional one.
Yes, it must be that one. At this point in the dismantling, Master Ken went into his usual reverse engineering trance and quickly came up with this cryptic hand drawing for the connectors and an associated cryptic schematic, adorned with some magical zodiacal signs. Most importantly, he was able to identify the connections to the AC servo motors. With this information, we should be able to power them up. An AC servo motor has 2 coils, an excitation coil and a control coil. The excitation coil is continuously powered by an AC voltage, usually large, in our case 115 volts 400 Hz AC. The excitation voltage also establishes the reference phase for the system. In contrast, the control coil is powered by a variable AC voltage, usually much smaller, coming from the servo control electronics. In our case, it ranges from 0 to 26 volts AC at 400 Hz. The control voltage should also be dephased from the excitation by roughly plus or minus 90 degrees in order to spin the motor in one or the other direction. The dephasing is usually accomplished by a capacitor in series with the control winding to achieve 90 degrees of lag. The plus or minus direction is then accomplished by a simple inversion of the control voltage. So this is exactly how we plan to wire one of the motors in our first test. Alright, Master Ken, you ready to power up your contraption?
Yep, I've wired up the 115 volts AC 400 Hertz to this box, and then what I think is the roll motor to the variable power.
Alright, let me get closer. How come you have safety squints and I don't?
Well, you've got regular glasses.
That's not fair. So what have you wired? What do you expect?
So the AC and then the roll motor. So if I'm correct, it should turn this way.
Do you have a capacitor? A phasing
Capacitor. That's what I forgot.
All right. We'll come back when we have a capacitor.
Moments later.
You have a capacitor added.
Okay, I've added a 0.47 microfarad capacitor.
All right.
So here we go.
Oh, as promised.
Look at that.
I am impressed. Oh wait, what just happened? We did not notice it at first, but it is obvious looking back at the footage. It looks like the indicator has released the magic smoke. Our slip ring is glowing bright red. That can't be good. At the time I didn't see it, but I sure did smell something funny.
I think it's hot because of your hot air gun.
No, this smells. This motor smells. Yeah, that doesn't smell too good. You might want, you are turned off?
Yeah, it's turned off.
So something is getting too much juice. So at this point we did not know what happened, so we just decided to turn the indicator around and try it again. Try it again.
Did you want with the ball or with no ball?
Well, with no ball. I was putting the ball will take too long there, so I have no time. Okay. It works. So it's just not servoed at this point.
Right.
It's impressive enough. It turns.
I should get a video for my...
Okay, you want me to turn it on?
Okay.
Wouldn't you know it, it worked fine. Still smells a bit, but not much. Nothing heated up either. However, after reviewing the footage, it became obvious that something went wrong and that some further investigation was necessary. Eric took the lead on that.
The following day.
Well, we are backtracking a little bit because when we rotated the thing, it started smelling funny, and then I saw some suspiciously sparky stuff, red wet stuff, and it looks like we have a short at an inopportune place.
Yeah, it's a soft short circuit. We've disconnected the wires here and proved that it's in the wiring between this point here and the slip rings down here.
You have to turn the assembly because so it's in the innards of the slip ring.
Yeah, so it might be inside the slip ring assembly here, or it may be down inside this sort of metal throat where all the wires go to connect to the slip rings. We measure about 40 ohms of resistance between them, even though they're not connected to anything else.
So a bad slip ring, and that might explain why that instrument was going to be tossed away, or had been tossed away, and just the components were taken off of it. Ooh, that's hard to repair, a slip ring assembly. Another thing you found out that the stuff that was disconnected were the needle indicators,
Yeah,
right? Those
those
are
are-
not pots.
Yeah, there are four needle indicators here.
Yeah, so there would be a big kind of galvanometer moving the needles, and that's what was
And those have been looted.
looted. Yeah, it was taken for another piece of equipment. I'll let you ponder on that one if there's any way to repair it. We eventually found the root cause of the problem much later, but I'm going to let you in on the secret early. It turns out that the slip ring had suffered from an electrical incident before. Slip rings are used to transmit a signal through a rotating joint. This one works by forming a sliding contact between rotating rings and fixed contact springs. Now look at the top of the left contact springs. Several of them are damaged and way too short. Looking under the microscope, you can see that the top of the missing contacts have actually melted down. There are telltale little balls of molten metal on top of these ones, for example, and we have not put any voltage on these contacts yet. But you can pretty much tell what happened. A wire with high voltage or connected to the ground must have accidentally touched the spring wires while the indicator was powered. A large current resulted and managed to melt the top of the contacts where the wire was touching. But even after this sparky incident, the slip ring should still have been functional, since the remnants of the spring wires were still touching the ring. Plus there are two spring contacts for redundancy, one on each side. However, the problem is that this caused internal and invisible damage to the slip ring. See the straight wires running up and down inside the brown tubular shaft? They are the internal wires to the other side of the slip ring. If you squint, you can tell that there are 3 wires attached to each ring. These have heated up during the short enough that they have started to connect to other rings along the way that they should never have been connected to. And this is what caused the short on the innermost ring. It burned a hole in the ring at the location where the insulation of the underlying wire had broken down. When we powered up the motor, this short heated up. It eventually burned through the ring until there was only a partial short left, which is why our motor functioned afterwards. Eric could measure the remnant of the short. Eric, you found the short?
Yes. Yeah, so it's between 2 of the slip rings here. And the probe points that I have here, these are on one and the other side. So like this one right here is the innermost slip ring.
Okay,
So
that's the one where the hole is and the glowing point was.
It's got a hole burned in it. And then this other one right here, this one's, I think it's the 10th one from the rear, so it's much closer to the rear. And it's completely different, and you might say, well, why isn't it shorted to an adjacent one? And that's because these all go to connecting wires that feed straight up on the inside.
And they probably touched just under where the hole is and the glowing point was.
And exactly, and so the glowing point was where that slip ring shorted to the wire that was underneath it, which presumably had bad insulation.
And I bet you that's why this thing didn't work and they used it as a spare.
That's right. So it's a soft short, like I said earlier, because we've got about 260 ohms.
Yeah, you had 40 ohms before, then you poked at it.
And then I poked the probe into the hole, and it kind of cleared part of the short. But I'm sure there's enough carbon from when it burned that it's just acting like a resistor now.
Yeah, so the question, can we rewire it to regain? Well, let's see what functionality we lost and see if we can snip something and make it work. Would be nice.
Later.
So after a lot of checking, we think it's not going to smoke again.
Well, we certainly hope not, but we'll have our finger on the power button just in case.
Okay.
Make sure we're cleared here. There's no wires sticking out. That seems okay.
Okay. Are we ready for 115 volts?
Yep.
I am.
Okay, we've got 115 volts.
And you don't have any volts there, or you're just doing the... Oh, you're...
Okay, I stopped it because, yeah, we have no volts coming out here.
Okay,
Let's again.
try number 2.
Okay, there we've got 4 volts.
Okay, it's coming up.
Yeah, it should be rotating by now, so I'm a little nervous that nothing is happening.
I don't see any...
No,
did you put a
no movement.
capacitor for the motor?
Oh yeah, capacitor,
Let's turn it off then.
that's what I figured.
Okay. Try number 3 with the capacitor.
We're up to 5 volts.
Should be moving by now.
Yeah, I would think so.
No torque.
Okay, that did not work so well. Let's try another axis.
Yeah, so we're going to go to what I'm calling the pitch motor.
Power on.
Oh, it switched. Oh, look, it's moving.
There we have rotation.
We have pitch.
We're rotating
We
it
have
now.
perfect pitch.
Oh, I wouldn't want to be in that plane right now, but... Okay, so nothing is burning.
Seems to be okay.
Alright. We move on to the third axis, which would be yaw.
Okay.
Let me turn it off again. Okay. Oh, it's already turning.
I don't see anything turning. Oh! You have to... Yeah, okay.
It's a little unexpected because I've got the amplitude turned down here.
Yeah, it's not changing speed.
Well, it may be self-excited, like stray magnetism.
Oh, you don't have any voltage on it?
No voltage on it.
I mean, there's voltage on the motor winding, but not the control winding.
Huh.
But normally it would be servoed to stay in one position.
But still, it
Turn it
should...
off. Let's try a W instead of X.
You shouldn't do that. Interesting. Now we have the opposite problem. Yaw rotates when it shouldn't, with zero control voltage. That will probably come back to bite us in a future episode. But for now, let's go back to the roll axis that refused to work. And you get the last axis going finally.
Yeah, it was just a wire that needed to be attached.
Oh, that's one of them that you had detached, chasing down the short.
Yes.
That does not exist anymore. Okay, so we have a working indicator.
All right.
So if we put the servo amp to it, that should work.
All right. Should I power it off?
Go ahead.
All
It's
right.
repaired.
Good work, team.
All right.
Okay, we think we have made good progress understanding this amazing instrument. But we have quite a few more hurdles to clear, after putting it back together, that is, before we get to something fully functional. We'll need to obtain the missing servo control electronics, reverse engineer and repair them. Only then will we be able to appreciate our indicator in its full glory. More adventures await in a future episode. See you then!